thank you everyone for coming to this talk. My name is Adam, as Mark says. I'm a software engineer at Bloomberg, and today I'm going to talk about AMQPprox, which is a proxy we've built to help our RabbitMQ as a service platform. On your screen is a quick roadmap of what we'll go through in the next 20-25 minutes. If I was going to ask you to take two things away, the first one is that I really hope some of you recognize the problems that we're hitting. We hope we're not alone. Maybe you're hitting the same problems too. The second thing is that maybe this talk will leave you excited, maybe a bit curious for whether or not AMQPprox could help you as well. And if so, look out for some good news at the end of the talk. I'll start with a quick introduction to Bloomberg. Some of you might have heard of us. We're a financial data, a financial news and analytics provider. The Bloomberg terminal sits on the desks of professionals throughout the financial world to provide them with up-to-date information so that they can make informed decisions. We also provide data feeds to organizations across the industry to feed their enterprise systems with different kinds of financial data. The Bloomberg terminal is made up of hundreds, if not thousands of products or functions, and we have over 6,500 engineers at the company. These engineers, as you might imagine, all want the best tools available. The kinds of products that they're working on dictates that these tools must be dependable, flexible, and predictable. And that's hopefully where our team comes in. What is it we do? We provide RabbitMQ as a service to internal engineers. And it's worth mentioning that there are other teams that provide a similar service for other middleware platforms. Teams at Bloomberg which are using RabbitMQ have chosen to use it. Now, if you were here at RabbitMQ Summit before COVID in London, you may have seen Will Hoy's talk, who's my team lead. He gave a talk giving a lot more detail about our setup, in particular the distinction between applications and infrastructure. If I were to quickly summarize, when someone at Bloomberg wants to use RabbitMQ, we hand them a vhost in the form of a URL and the keys that they need to access it. It's our job to make RabbitMQ as easy to use and as stable for our users. And from our perspective, we want it to be as maintainable as possible so that we can give internal engineers a good experience. So now our users have a vhost. What is it they expect from Rabbit? And I think the best, most honest answer I can give to that is literally everything. Some of our users need incredibly reliable messaging with persistence turned on. Some of our users would prefer maximal performance. And if you were to take the top 10 program languages in the world used with RabbitMQ, we would have all of them. And the same is true for AMQP libraries too. In case you're getting this idea, providing this service isn't always straightforward, and we've had to adapt the platform over the years to get there. Once upon a time, RabbitMQ at Bloomberg would have looked like what you can see on the screen here. So we would have had one client which had one vhost, and that vhost was running on a single RabbitMQ broker. These days, the picture is very different. We have many RabbitMQ brokers, and we have many, many more clients. And as you might imagine, as we've evolved, we've hit a few problems along the way. If I were to pick the two biggest problems we face trying to build a dependable and maintainable RabbitMQ platform, it's got to be these two. So the first one, I'll start with broker upgrades. Our clients expect us to be running a recent version of RabbitMQ, and that doesn't mean that it's the version that was announced yesterday, but if they Google something and it says that RabbitMQ can help them help their application in a particular way, they expect us to be able to provide that same service. This kind of contradicts quite neatly with what I'm going to call client requirement number 2, which is that a full cluster stop is unacceptable. And that's because this could mean minutes of downtime, and that's assuming the upgrade goes to plan. These two requirements combine together to sort of push us down the path of rolling upgrades. But although it's fair to say the story here has gotten a lot better with RabbitMQ 3.8, we still can't fully rely on this, particularly given we need to go through Erlang major version upgrades. So that's the first problem that we've had. The second problem is load balancing our brokers. We run multiple vhosts per broker, and we place new vhosts onto quieter brokers, but usage patterns shift over time. And to provide a good service to everyone, we want to be able to evenly load our brokers. The tool which we want to achieve both of these things is to move a vhost from one broker to another. So in the load balance example, if we have two clusters, one's very busy, we want to shift some of the load to the less busy cluster. So this is where we want to get to. Now I'm going to talk about what we tried and what didn't work for us. The first thing that we tried, this is what we used to do, was we would reach out to our users and say, hey, you're currently on broker X. We want you to move to broker Y. And the way that we would instruct them to do this is first by moving their producers so that their producers produce to both brokers, then switch over their consumers. Then they can tear down the producers to the old broker. At that point, they reach out to us and we can remove their vhost from the old broker. Job done. This isn't particularly difficult for us, but this is an incredibly invasive change for our clients to make to their applications. And it's a tough sell to ask them to do this at short notice. For example, if we need to load balance some of our brokers. I think it should be clear that this doesn't scale to hundreds, let alone thousands of applications. So for that reason, this method is out. Something else we thought about was, could we inject some logic into our client applications? So we could own some code that sat between the business logic that they're writing and the AMQP library that they use right now. This could let us control not only which broker they connect to, but maybe we could do something fancy here, like move their publishers automatically and followed by their consumers. There's some scope there. The challenge here is that how many program languages should our team support libraries in? Because we kind of need to be very knowledgeable in that to provide a good interface for our clients. But the bigger problem is that our team might block the adoption of something new that we haven't heard of before. And that doesn't really sit right with us as infrastructure providers, and it definitely doesn't sit right with our users. So for that reason, this method was out. Something else which we've tried and thought about is running something like HAProxy or any layer 4 proxy in the middle. And HAProxy is a very powerful tool when you use it with RabbitMQ. You can sit it in front of a single RabbitMQ cluster, and it's going to load balance connections across that cluster, which is important to provide a good service from all of those nodes. But the challenge here is that HAProxy can't read far enough into the AMQP protocol to understand which vhost the client wants to connect to. So we can't use it to switch a vhost from one broker to the other. So this method didn't work for us. At this point, we've talked about which methods didn't work for us. Now I'd like to talk about what did. So introducing AMQpprox. AMQpprox is a smart, vhost-aware RabbitMQ proxy. AMQpprox sits in front of all of our RabbitMQ connections, and this lets us control not only the initial broker connections, but it also lets us intervene in established connections later on. At its core is a mapping from vhost to broker. And using this mapping, it can direct AMQP connections to the right place. So it has a mapping. How does it use that? AMQpprox speaks just enough AMQP 091 to learn the vhost from the initial handshake. On screen, we've got an example where a client wants to connect to a particular vhost, and it happens to be that that vhost runs on the broker that's on the right-hand side. So to start with, the client's going to connect to AMQpprox in the middle, and it will handshake with AMQpprox up until the point where AMQpprox learns which vhost this client wants to access. And that's way down here in the connection open frame here. Once it knows which vhost the client wants to access, AMQpprox can connect to the right broker. And it will do this by replaying the same frames that the client gave to it earlier on. Once we're at the point where both of these connections are level, so AMQpprox has sent the connection open frame. At this point, if everything goes well, the broker is going to reply with open OK, and it's at this frame and all frames afterwards are going to get forwarded transparently. So the client thinks it's talking directly to the broker, and the broker thinks it's talking directly to the client. Now we've talked about how AMQpprox works, let's take a look at how to use it. As I mentioned before, the core of AMQpprox is a mapping between vhosts and brokers. In this example, we're going to set it up like we see on screen. We have a user on the left who wants to access vhost A, and their vhost is running on a cluster called broker X, and this cluster is made up of 2 RabbitMQ nodes. So we need to teach AMQpprox about the cluster that it's connecting to and also the vhost that the client wants to access. First of all, let's start AMQpprox. You can do this by using the command at the top. And the important thing to note is that when AMQpprox starts up, it waits for commands. It has no mappings, it has no config file, and at this point, it isn't listening for AMQP traffic. Config is all passed using AMQpprox CTL, which uses a Unix domain socket underneath. That's all wrapped up using the CTL command. And on screen, you can see what happens when you ask AMQpprox help. You get back a list of the commands that it supports. So let's get configuring it. First of all, let's teach it about the first broker cluster node that we want it to learn about. We're using the terminology backend here. So for this, we use the backend add command. The first one we're going to call broker x1. We'll give it a data center label of London, and we'll say that this node is accessible on localhost port 8000. Next, we're going to do the same again for the second node, broker x2. Say it's running in the same data center. This time it's on localhost port 9000. Next, we bring those two nodes together into a farm or a broker or a cluster. We use the farm add command. You give the farm a label of broker X. We give it the two backend nodes, broker X1 and broker X2, and we say that it should select between those nodes using the round robin algorithm. And then we want to update that mapping that sits at the core of AMQPprox using the map farm command, say that vhost A lives on the farm broker X. So at this point, AMQPprox has all of the knowledge it needs to map the connections, but if a client tried to connect, it still wouldn't get through. And that's because we need to tell it to start listening. Once we've done this using the listen start command, a client can connect to the program, say it wants to talk to vhost A, and the connection will get routed correctly. So that's how you run AMQPprox and you configure it for a simple example like that. A nice thing to point out is that all of this config can change at runtime. For example, we use similar commands to what I just described before to dynamically add vhosts and brokers on the fly. But that's not the only thing that you can do. AMQPprox has a few extra commands too. The first one I'd like to talk about is vhost pause. You can pass this command a vhost name, and what this does is it stops passing frames between the broker and the client. On top of that, new connections that go through, when we get to the connection open frame where the client says which vhost they want to connect to, they will get held if the vhost is paused. The opposite to pause, as you might have guessed, is unpause. And what this does is allow new connections for a particular vhost to get through to the broker again. This is often combined with forced disconnect, which is going to, as you might imagine, cut both the broker and the client connection for everything associated with this particular vhost. And as I touched on before, everything can change at runtime. And at the bottom, you can see an example of us teaching AMQPprox about vhost B. And we start off by saying it lives on broker X. And then immediately afterwards, we say vhost B actually lives on broker Y. And what this means is that for the latest mapping, when a connection comes in, the new connections will get routed to the latest broker, so broker Y in this example. The special thing about these commands that I'm talking about here is that we can use these to orchestrate moving a vhost from one broker to the other without touching the client that's connecting. So to do this, first of all, we want to pause the vhost that we're moving. We want to kick off all the clients associated with that. At this point, the state on the RabbitMQ broker should settle. Things like auto-delete queues, etc., will disappear. If you wanted to perform this migration without the application noticing, now's a good time to take a snapshot of that state and move it to the new location. Once we've done that, we want to update the mapping in AMQPprox to say that vhost A now lives on broker Y. We can unpause the vhost, disconnect those connections, and then when the clients come in, they're actually talking to a completely different broker without them knowing that it's changed. We can use this to safely move clients from one broker to the other without having to change them, which is very, very powerful. For us, the main thing that we get, one of the main things we get is a nicer RabbitMQ upgrade path. In terms of how we perform an upgrade now, it looks like this. We can stand up a new cluster. We can pick a version of RabbitMQ and Erlang. We can test it out, check that this all works for us, check that our infrastructure is compatible. Then vhost by vhost, we can move applications over to this new cluster. And the really key thing is that we don't tear down the environment where they were stable before. So if we move someone and then they have a problem, they're incompatible with the version, we can perform the same operation in reverse and put them back where they were happy. Having a good rollback plan is just as important as having a good rollout. AMQPprox also gives us a few tools to handle what I'm going to call proactive load balancing. So not only similar to what HAProxy can do, as I described earlier, AMQPprox is going to balance connections to a particular broker cluster. We can now do what we wanted to do and move vhosts between brokers to make sure different brokers have similar load. Another thing that maybe is a little bit less obvious is, say, for example, you have right now you have two RabbitMQ clusters, and both of them are very busy. If you wanted to, you could spin up a third RabbitMQ cluster, and before we had AMQPprox, that cluster would sit there unused for potentially weeks at a time while we waited for clients to move and make use of the new hardware. And that's incredibly wasteful. But now we have AMQPprox, and we can move vhosts over to the new hardware. It will get utilized straight away. The other aspect where AMQPprox helps us out is what I'm going to call reactive load shedding. And to describe this, I'll tell a little story. So one day, someone ran a load test in dev, and our health checks and other vhosts on the broker suddenly saw their confirmed times jump. Clients reached out to us and said, hey, why is RabbitMQ taking 20 seconds to confirm our messages? This is affecting us. And at this point, we now have a few options for what we can do. The first thing we can do, and maybe the most drastic thing, is we can unmap this vhost and force disconnect all the clients. When the vhost that's performing their load test tries to reconnect, those connections are going to bounce at the proxy, and that's a cheap operation that it can sustain. This is nice because it means that all the other vhosts on the broker can get back in business as quickly as possible and get on with their day. But we also have a few other options. We could, for example, move the vhost that's performing the load test to an isolation or doghouse cluster, as we call it. And this is in some ways better because it means that not only does the vhost on the original broker can get back to the job, get back to what they were doing, but the team that's doing this load test doesn't get completely disrupted. And it gives us time to reach out and ask them, hey, is everything okay? How can we help? And finally, the third option that we've got is if some vhosts are being affected on a particular broker, perhaps they're just a little bit sensitive or they have very important clients, what we can do is move the vhosts that are being affected to this isolation cluster. And that means that if they're doing particularly important work, they can get back up and running as quickly as possible. Something else that AMQPprox helps us out with is integration testing our applications. In particular, in scenarios where it's difficult to do this directly with RabbitMQ. So the first one I'll talk about is making sure your application actually handles heartbeats correctly. In this case, you can run your application in some kind of test environment, connect it to a proxy that you control. In that proxy, map it to a particular RabbitMQ broker, then use the vhost pause command, and that's going to stop passing the frames, including the heartbeat frames. And at that point, you should be able to verify that your application is correctly noticing that the broker is missing, disconnects, and reconnects. Something else that AMQPprox can help you with is testing your application on multiple versions of RabbitMQ. You could set up the proxy to talk to, say, 3.8.16, and then run your test suite, and then remap the broker in the proxy to be, say, the 3.9 release candidate, then run your tests again. And this lets you test that your program works on multiple versions of RabbitMQ without having to either upgrade a broker during your tests or change the configuration in your application, which can be pretty handy. On screen now are a few other features that AMQPprox supports. I'll just talk through a couple of them though. So the first one I'd like to highlight is proxy protocol. If you turn this on the broker and AMQPprox, then when you look at the management UI or you look at the RabbitMQ logs, all those client connections which are coming in are still going to show as though as they looked when they connected to the proxy. This is really handy for both us as infrastructure providers and our application teams to let them figure out where connections are coming from, what's consuming from queues, etc., etc. On top of that, AMQPprox will stamp on some client properties for the actual host that this connection has bounced through, which is useful for debugging. Another really important part about running applications in production is making sure that they're observable, and AMQPprox is no different here. We use statsd to publish some observability metrics, and internally we have some dashboards that we can monitor and alarm on to check that everything's okay. And the last thing I'll touch on here is that AMQPprox isn't particularly resource heavy. We have a lot of success running this on fairly small machines, which is something I'll touch on again later on. So we've talked about what AMQPprox helps us with, but there's some downsides to it too, and it wouldn't be fair to skip over those. So again, on screen are a few, and I'll just touch on a couple of them. The first one to mention is this synthetic initial handshake. So when the client wants to connect to a broker, it talks to the proxy, and it's only quite late in the handshake that it actually says which vhost it wants to connect to, which is really the important part for making the decision for which broker to connect to. Up until that point, some important characteristics about the connection have already been agreed. In particular, I'd like to note about max channels. In reality, we found this hasn't really been an issue because we configure AMQPprox to just send the same number of max channels as all of our brokers have set up. But maybe if your setup is different, you need to have a bit more care there. Another point to mention is that AMQPprox accepts a TCP connection and then opens another one outbound. And it's very easy to exhaust the number of ephemeral ports on the machine that you're running it. For this reason, I'd recommend running AMQPprox on many small machines rather than a few large machines. And then the final thing to touch on is the way that we are doing vhost migrations requires the broker to respond to grab the state halfway through. If the broker, well, I guess I'd say that this is fine normally because we tend to move vhosts when we're upgrading RabbitMQ or we're performing some kind of proactive load balancing. But if the broker is fully unavailable and we need to skip the state migration for some reason, this can affect the applications, as you might expect, because RabbitMQ is a stateful program. If anybody has or knows of an open source tool which can let us extract this state from an offline broker, then do reach out. I'd be interested to see that. So far we've talked about what AMQPprox is, how it works, and what it does for us. I'm hoping this sounds interesting to some of you. And on that note, we're really excited to announce that AMQPprox has been published to GitHub. You can take a look at it and use it in your RabbitMQ deployments. If you did look through, you'd see that it was a modern C++ async application, and we use Conan and CMake to help us build it. I can recommend taking a look at the Getting Started section in the README. This is going to get you up to speed with how to build, how to run, and how to configure AMQPprox for your installation. And I'd also highlight that there's a nice page on this repo which will go through everyone who's been a part of getting this project here today. I encourage you to take a look at that. If anyone has any questions, please do put them in the chat now or reach out after the talk. If you find any problems or missing features, do open an issue or even a pull request. We're really excited to engage with the community and maybe even receive some contributions. Now, some of you might be thinking this sounds really interesting, but can it actually support real workloads? And I'm pleased to say that although this is a conference for rabbits, this is no pet project. And to back that up, here are a few statistics. So we've been running this in production for quite a few years at this point. Back of the envelope calculation says we've got a few million cumulative hours of uptime. And on a daily basis, we handle somewhere around the region of 50 million connections established. When I was taking a look through some of our metrics, I saw that one node in particular hit 5 gigabit per second, and all of that processing is happening on a single core. When we started using AMQPprox, we did just a few vhost migrations, but these days we can do hundreds. New versions and expansion of our RabbitMQ clusters has kicked off a lot more of these. And the final thing to note on this slide is that these aren't synthetic benchmarks, and I'm hoping that goes some way to back up our claims that this can handle your production workloads. Now, I hope AMQPprox sounds interesting to you, and if so, do let us know via issues and contributions. Thank you very much for listening, and can I answer any of your questions? I'm just going to switch to the keyboard.
Adam, thanks very much. That was a very interesting talk, and I've learned a lot there. One question that I'll ask myself is why didn't you write it, or why didn't you use Erlang or Elixir?
That's a good question. I think the honest answer to this is that my boss wanted to learn C++11 at the time, so this was a good project for that. But perhaps like a more genuine answer is that we have lots of institutional knowledge around C++, and we're much newer in the Erlang Elixir space, so it made a lot of sense at the time. If we were to write it today, maybe we'd pick something like Rust, but who knows?
Why not? Okay. Matt Davey, you have a question. Are you there?
Hi, can you hear me?
Yes, perfectly.
Yeah, I was wondering how the proxy handles authentication, because those packets are transferred before the connection opens. So does it just kind of temporarily authenticate and then try later once it starts talking to the broker?
That's a good question. So when you connect, I guess the authentication happens. I guess I can pull up that part of the handshake. Apparently not. Yeah, when you connect, you send your SASL authentication step. Right now, AMQPprox just copies that over to the next stage in the process, so it will just send that same information to the broker. I would say that there's a pull request open on the repo, something we're working on at the moment to extend how the authentication works to hook into some kind of external service. So watch this space.
Thank you. Matt, did that answer your question?
Kind of. Just one follow-on question. Does it kind of, when it responds to the client in response to the authentication packet, what does it actually tell the client? Does it tell it it's authenticated before it's actually connected to the broker?
Yeah,
okay.
The client thinks it's authenticated, and then if the authentication with the broker later on fails, then it's just going to get disconnected.
Okay, that answers my question. Thank you.
Thank you. Michael Denny, you have a question. Would you like to unmute and ask?
Yes, thank you. Would you suggest amqpprox even to ones that you just, even to the ones that just need the connections balancing, or you suggest amqpprox also to the ones that need those also vhost balancing? I mean, do you suggest to the ones that just need connection to stick to HA proxy?
That's a really interesting question. Yeah, thanks for that. I guess to understand it, if you've just got one RabbitMQ cluster and you want to just load balance for that one cluster, should you bother with AMQPprox? If I'm understanding your question.
Yes.
Thanks. I think I would answer that. It depends where you're looking in the future, because AMQPprox, if you are running one cluster right now, but you're worried about hitting performance problems in the future and you want to be able to split your cluster into multiple clusters, AMQPprox, if you put it in early on, is going to make that process really easy. On top of that, it's going to make it a lot easier to adopt a blue-green upgrade workflow, which in our experience makes dealing with RabbitMQ a lot easier. So even if you just run one RabbitMQ cluster, it provides a few features which are going to be quite interesting.
Okay, thank you.
Okay, we have another question from Matt Green. Do you want to unmute Matt Green and ask a question?
Yeah, perhaps I missed something. Your presentation was quite good, provoked a number of things for me to think about. But you pause your connection to a cluster, and then you move over to a new cluster. But what's happened to the? Is there another process that takes care of the metadata? You know, users, queues, blah blah blah. That's something that we would need to take care of. The proxy's just taking care of the connection. Is that correct?
Yes, thanks for your question, Matt. That's a really good question. So as you're saying, the proxy is just handling the TCP connections. At the point where you've paused your vhost and you've disconnected your clients, then there's this kind of nebulous step, which I haven't described in great detail, where you need to fetch that metadata from the cluster so you can export that. You can import that into the new broker, and then you can use either Shovels or the Federation plugin, I'm told, has some kind of support here to then move the data over to the new cluster. In particular, I think your question might have mentioned unacknowledged messages. Okay,
you've covered what I wanted to know. Thanks.
Okay,
there was a second part. Do you have a load balancer in front of 3 or 4 of these proxies in effect to make it, or do you just have one proxy running?
We just use this as our only proxy. I guess we use DNS a little bit to load balance across this proxy cluster, but it handles the load balance. It can handle the load that we throw at it without something else in front.
Okay, thank you very much.
Thank you for your question. David Ansari, you have a question, perhaps you could unmute and ask.
Yep. Yeah, it looks like you use AMQPprox for blue-green deployments, blue-green upgrades. Do you use rolling upgrades nowadays, or do you use a mixture of both? And if so, when do you decide to use which approach?
That is a good question. I would say historically we used to do rolling upgrades, but we had a few problems along the way, which kind of drove us into developing this. Since we have this in place and some other things have happened, we've preferred to blue-green deployments because it means that whenever we upgrade, we get like a fresh slate. Like there's no like metadata hanging around in the broker from previous runs. It could be that we want to look at rolling upgrades for like very small patch changes in the future, but the advantages we get in standing up a completely new cluster and QAing it means that like if some kind of behavior change sneaks into a patch version of RabbitMQ, we can validate that before we put clients through it. And really the ability to migrate clients not just to the version, but also back from it seamlessly is important to us. So I think we're going to stick with blue-green upgrades going forward.
Thank you. Matt, sorry, Mark, Adam, sorry, my brain's getting scrambled, it's late at night. Do you have any future plans?
That's a good question. So on the GitHub repo, let me try and pull it up. Always a bad idea to do this while you're trying to talk.
It's always bad to do live demonstrations.
So I guess I touched on one of these earlier, one of the earlier questions about authentication. There's a pull request open at the moment to add some things around in that space. Something else that I guess came up very recently is this isn't going to support the new stream binary protocol out of the box. And so we'll need to have a think about how that's going to look. In particular, I guess one interesting part of that is that in the protocol, you can query the broker to say which URL it should connect to next. And if you're going through something like a proxy, that's quite a difficult question to answer. So there's definitely going to be some work there. And on the GitHub repo, we have a little roadmap. So if anyone has any other ideas or directions, and this is a good reference point to start.
Thank you. I don't think there's any more published or posted questions at the moment. So if anyone's got some questions, perhaps they could think them up and shout. Please, I must remind you to rate the talks. It's always good to give the presenters some feedback on what you think. All good things, please. Nothing unpleasant. Also, there's a quiz that's floating around where you can win some Amazon vouchers. Well worth having a punt at that, because if you don't take part, you won't win. And apart from that, has anyone else got any questions? Any further questions?
I have a comment and possibly a question.
Please.
The comment is that there is an option to tell RabbitMQ what URL to advertise for the stream connection. So what we used to do in the very early days, we used to always advertise the proxy or the load balancer, in our case, address URL. So what that meant actually, I think, was like a host. Anyways, the point being, you can let any node advertise the proxy or load balancer. So effectively, there's like an extra thing to do, but still, you can tell it to just go the way you came, and it'll be fine. Now, the problem with that will be when it comes to publishers. They're a bit more tricky. So yeah, but still, it can work. The question is, you mentioned about some bad experiences around rolling upgrades. Can you give one, like the worst one, a specific worst experience about rolling upgrades?
I think some of my New York colleagues will be squirming if I don't answer this. So I think we went to, a while back, tried going to 379 to 3715, something along those lines. And the problem we had was we would start the upgrade process and it would get some way into doing the upgrade, but for some reason it would fail. I don't remember the precise details of why it failed. But then the problem that we've got is that we've been offline for a number of minutes while this upgrade is happening. Well, I guess while a node upgrade happens. And then if you get stuck, for example, if the final node isn't going to restart properly, then we need to go backwards somehow. But we've erased all of the state that we had up until that point. So the downgrade process wasn't very smooth either. I think that's probably the most recent example that I can give, unfortunately.
That's a good one. Thank you. So it was a patch upgrade is what you're saying?
Yeah, it was a patch upgrade.
Okay. And I'm assuming that was unexpected.
Yeah.
Okay.